Welcome to the video tutorial on how to configure PageGate's Serial2ASCII module. In this tutorial, we'll be going over how to configure Serial2ASCII to monitor a COM port or Serial/RS-232 port. Serial2ASCII is a companion module for the Get Serial interface and unlocks the ability to monitor additional Serial/RS-232 ports up to as many as you may need. Messages received by this module are output to a directory as a text file that is then read in by the getASCII API. This module requires the getASCII API to function. The first step is to create a directory for the Serial2ASCII receiver. This can be any folder accessible to PageGate, whether on the local hard drive or by UNC path to a network resource. However, if PageGate will need to reference a network resource, the services relevant to these processes will need permission to access it. For more information on this, please see the Run Styles section of PageGate's documentation. I recommend creating a subdirectory of the PageGate data folder and calling it Serial2ASCII X, where X is the number of the interface. By default, /PageGate data /Serial2ASCII1. After you purchase the Serial2ASCII module, you'll be sent a zip file containing the relevant files for the module. You'll want to unzip the Serial2ASCII zip file into the folder you just created. By default, /PageGate data /Serial2ASCII1. Next, open Serial2ASCII.ini in your preferred text editor like Notepad or WordPad. To give you a little more information, this INI controls the behavior of the Serial2ASCII receiver. Change runStyle equals application to runStyle equals service. Change switchStyle equals false to switchStyle equals true. Set data folder to the directory you created for the Serial2ASCII module. By default, you would set data folder to /PageGate data /Serial2ASCII1. Set the COM port to the COM or serial port that should be monitored. Set COM settings equal to the communication parameters required. Values must be passed as baud rate, parity, databits, stop bits. For example, this string would use 9600 baud, with no parity, 8 databits, and 1 stop bit. And this init string would use 1200 baud, with even parity, 7 databits, and 1 stop bit. Next we have the symbols section. The symbols section declares that certain characters should have special functions. The single character wildcard is a character that can be used in a search pattern to designate a location where any single character or symbol will be accepted as a match. For example, if question mark is the single character wildcard, then the pattern $USE would be a match for words like fuse, muse, and ruse, but would not match amuse or reuse. The multiple character wildcard is a character that can be used in a search pattern to designate a location where any group of characters and symbols will be accepted as a match. For example, if asterisk is the multiple character wildcard, you could use the pattern *USE to find muse, fuse, ruse, amuse, accuse, or any other word or alphanumeric sequence that ends with the characters USE. When used by itself as a start pattern, the multiple character wildcard would always match the first character of the input text. The end of record symbol is a character that can be used in a search pattern to designate the last character of the input text, regardless of what that character is. The end of record symbol is most commonly used in end pattern fields as a value that means the last character of the input data. If this character appears within a data stream, the program will stop reading at the character and will treat everything after it as a new data stream. The ASCII value delimiter is a character that means the next 3 digits stand for an ASCII character value. This is normally used for expressing non-printable characters like a carriage return, line feed, horizontal tab, or other control character. For example, \013 would be the ASCII designation for a carriage return, and \010 would be the ASCII designation for a line feed. Next we have the record section. The record section designates what part of a data stream contains the messaging data, for example, recipient, sender, and message. For example, assuming asterisk is your multiple character wildcard, if you use an asterisk as a start pattern and \013 as an end pattern, that would tell the module to treat everything between the very first character received and the very first carriage return received as a record. As another example, you could use the word start as the start pattern and the word end as the end pattern. That would tell the module to treat everything between the words start and end in your data stream as a record. Basically, we're telling the module that everything between the declared characters is relevant. You'll also notice that there are start offset and end offset values. The start offset represents the number of characters before or after the start pattern to begin reading, and these values can be expressed as positive or negative values. For example, if you were using the word start as your start pattern, you could use a start offset of 5 because there are 5 characters in start. That would tell the program that the word start isn't relevant for the recipient, sender, or message. Using a value of -5 would say that 5 characters before the first character in the start pattern is the beginning of the record. The end offset, on the other hand, represents the number of characters before or after the end pattern to not include in the record data. As with start offset, these values can be expressed in positive or negative values. Now that we've declared what the record is, we'll need to configure the recipient parsing. The recipient section determines where in the record data the recipient or group name can be found. However, if you want all messages triggered on the serial line to go to a specific recipient or group, you can enter the name of a recipient or group in the static section. If static has a value, the start and end patterns are not referenced, and all messages will be delivered to the static recipient or group specified. If the data stream contains information about whom the messages should go to, you'll need to tell the module where in the data stream that information appears by configuring the start and end patterns as well as their corresponding offsets. The start and end patterns tell the module that everything between the declared character or characters is the recipient or group name. For example, let's say that your data stream looks something like this, and that unit 3 represents who the message should go to. Remember the start offset in the record? We set that to 5, so when the module scans for recipient information, it's actually searching on this line. In this case, we would use an asterisk as our start pattern to tell the interface that the recipient information starts at the first character. Then, we would use alarm as our end pattern. This tells the interface that everything between the first character and the word alarm is the recipient information. Now we'll need to configure the sender section. The sender's name is text that will appear before the message to denote who or what sent the message, and is used to construct the mail from value when PageGate needs to deliver email. This section determines where in the data the sender's value can be found. This section uses the same pattern matching as the recipient section and can be configured similarly. Typically speaking, though, most systems won't pass a sender's name value in the data written, and you'll want to write a static value in the static field. If there is a value in the static field, the start and end patterns are not referenced, and the module simply uses the value specified. The final section is message. The message section determines where in the record the message can be found, and uses similar start and end patterns to the other sections. To use our earlier example, let's say that our original data stream looks like this, and this is what it looks like after the record declaration, and this is what it looks like after the recipient declaration. The remaining portion of the data stream is available to be scanned for the message. If all of the information is relevant, you can use an asterisk as a start pattern, and a tilde as an end pattern. That would configure the interface to treat everything from the first character to the last character as the message. However, we could also use the word alarm : as the start pattern with a start offset of 6. But that makes the assumption that every message will be prefixed with the text alarm : If that text does not appear, but is specified as the start pattern for the message, the interface will not recognize it as a valid message. When finished, save and close the INI file. Next, open pininfo in your preferred text editor like Notepad or WordPad. This file tells Serial2ASCII what range of numbers can be accepted as valid IDs. The format of the entries defined are as follows. The first value is going to be the starting pin. The second value is the ending pin. And the third value is the recipient type. If you would like ID numbers in a range to be recognized as a recipient or group's name, so not using an ad hoc setup but actually using a static recipient or group setup, use the text PG_recipient as the third value. For example, this would configure the module to accept any 4-digit numerical ID as a recipient or group name. If you would like ID numbers in a range to be passed through the module as intact IDs to another source in an ad hoc range, use the name of a recipient in PageGate whose type is ad hoc. For example, this would configure the Serial2ASCII module to accept any 7-digit ID as a free-form value to pass to the ad hoc recipient named adhoc1. After declaring the appropriate ID ranges, save and close the file. Now that we've configured the Serial2ASCII module to receive messages, we'll need to create and start its Windows service. To do that, run a command prompt with elevated permission. To do so, go to your Start menu and search for the word Command. When Command Prompt comes up, right-click on it and select Run as Administrator. Next, change directory into the Serial2ASCII receiver's program directory. By default, C:\PageGate data /Serial2ASCII1. Once there, type the following and hit Enter. Serial2ASCII1 / install. Now open the services list in Windows and find the Serial2ASCII1 service. Right-click on it and select Start. The final step is to configure the getAscii API to process the Serial2ASCII module's messages. To do so, open the PageGate admin and go to the Interfaces, getAscii, Settings. If you already have a polling directory specified, you can skip this step. If you do not have a polling directory specified, we would recommend creating C:\PageGate data /ASCII and specifying that for your base polling location. Next, go to Interfaces, getAscii, Settings, Advanced Polling, Files. Click Add. Specify the following. Leave the recipient as an asterisk. In the From field, you can enter a sender value, or you can leave this field blank. In the Files section, specify *S2A. In the Path field, specify the output path of the Serial2ASCII receiver. By default, C:\PageGate data /Serial2ASCII1. Leave the file type at Standard. Click Apply, then click Apply again. At this point, the Serial2ASCII receiver is monitoring for your serial messages, and the getAscii interface is configured to process those messages once they're received. This concludes the video tutorial on how to configure PageGate's Serial2ASCII module. For more information, including an overview of the getSerial interface, please visit our website, www.notepage.net.